All right, so we are in AP Calculus. Today's date is Monday, September 28th, 2020. Our objective today, Fiona. This is very quiet, but it is correct. That is the objective. Should I also talk really quiet for today? No, okay. So definition of the derivative. You guys know this, but let's go ahead and see the graphical version of this. Go ahead and draw a secant line between this point at c, comma f of c, and this point c plus h, comma f of c plus h. So just draw a line between these two dots. That's the simple way of saying that. This represents the secant line. The slope of the secant line is its average rate of change, which you guys know the formula of, right? Because that was the first thing that we ever did. 1-1, our lesson, our slope was what? What's the definition of slope? All the way from Algebra 1. Okay, you're gonna have to go a little bit louder. Sorry, I can't hear you. Mx plus b. So that's the point, or that's slope-intercept form, which is a way to graph this line. I'm just looking for a formula purely for just slope.
Is it? Never mind.
Go for it. No, let's hear it.
No. Got it. Okay. Got it. Okay.
Breakfast and lunch today are going to be picked up at the Boosters booth outside in the back, since we're eating outside. Woo!
Wait, so how's that gonna?
What do you mean?
Like, is it just gonna apply the circles as in here as up there? Like,
There's no assigned seating out there. Just stay 6 feet apart.
oh, that should.
Yeah. All right, so slope. Here is the definition of slope. You start with f of b minus f of a. And give yourself some room. We're about to write something in this little space right here. So we're going to do f of b minus f of a. And hopefully this is reminding you. Oh, this is from, okay, so I have to use these letters though. Our second point, this is Algebra 1. In Algebra 1 we use this. We use y2 minus y1 all over x2 minus x1. And I have slightly different notation. My y's are f of something, but it's basically the same thing. All right, so, oops, x of 1. So I have f of c plus h. That's my second point, f of c plus h. Minus what? What's my other y coordinate? It's f of something, right? F of what? What's the only other f in there aside from the f of x, which is the general function? There it is. Yep, right down. Chris has f of c, which completes the numerator. What about the denominator? What's our? We're going to do our second x coordinate. Chris is on fire today. Yeah, c plus h. C plus h, and then I'm going to subtract what? C. Andrea and Chris have it. C. That's slope. That's just our definition of slope. Okay, so what I'm going to do is I'm going to take the limit as h gets smaller and smaller. What do I mean by that? And let's really analyze what's going on in this graph. So all I did was I chose a random point c. It could have been here, here, it doesn't matter. But then I said, okay, I'm going to go ahead and choose a number h that's positive. So when I add c plus h, it's going to be some distance. When h gets smaller and smaller, at this point I'm going to drag all the way and eventually overlap on top of c once h gets closer to 0. So I'm going to take the limit, and everyone's going to write this down with me, the limit out front of this function as h approaches 0. I want to create this distance between c and h. That distance is eventually going to not exist, and they're going to be on top of each other. Okay, so what we're saying here is that eventually is going to be the definition of the derivative. So what I can say out here to the left on top of this is that is f prime of c. That's what it means to take the derivative. I have a secant line, and I get less and less distance between the 2 points until the points are on top of each other, and that is the derivative once they're on the same point. And you can simplify this a little bit, right? This is now turning into a little bit easier. I can say f prime of c is equal to the limit as h approaches 0 of, okay, the numerator I can't simplify, so I'll just rewrite it. F of c plus h minus f of c. All of this divided by what? How can I simplify the denominator? I had c plus h minus c. Fiona? H, yeah. And hopefully this is a little bit unsettling to people. Like, wait, when we take limits, don't we just plug in whatever our suspect point is, this 0 in here? And you're like, oh, I want to be divided by 0. And that's where we might feel a little uncomfortable, but that is still the definition of the derivative. Okay, and I think I might have an animation for this to show you guys. I made it last year. Let's see if I can find it. And I don't see it, so I guess I don't have it. All right, so let's do what we're doing in our formula in words. As h gets smaller, the slope of the what line gets closer to the slope of the other line. What is the slope that we started with? It's just with an S. This black line? Secant, yeah. Teflon and Chris have it. The secant line. And it's eventually going to get closer to the slope of the t tangent, yeah. Okay, so for our homework, our worksheet tonight, you're going to have a bunch of these derivatives where I actually put in numbers in here. Instead of saying f of something, I say e to the 2x plus 1 or something like that. And you have to figure out what the function even is. So how do you do that? And it's John Wynn created this thing called the Hotbox, which is kind of funny to say out loud. But it's this. So if I have the derivative and it's set equal to it's the definition of the derivative, you're first going to find the hotbox. What do I mean by that? It's anything that has the c plus h, or anything that has an h in it on the top left. Typically it's going to be on the top left, and let's box it. That is going to be the box that is hot. So we're going to box it. Why do we do that? Everything else, ignore. It's to draw your focus onto the top left, the actual function. Okay, you're going to find what C is and you're going to write it down. It's the thing that's being added to H. So if I had to write a note over here, it's the thing being added to H. And the other note I can say for the hotbox, for step 1, it's usually in the top left. Usually in top left. Okay, wherever you see a C plus H or anything, like any addition, go ahead and cross off all of that. You're going to replace the C plus H, so I'm crossing it off. There it is, it's gone. And I'm going to replace it with just an X. So really what I have in here is an f of x. And that's our function. So our function now is really that f of x. And this will make sense once you see an actual example. And then once we have that function, you can now take the derivative of a function because you are really experienced at that, and then you can plug in c into the derivative. So those are our steps. Let's go ahead and try to do it on example 1. I don't know why. Oh, because there's not a future example. We're done after this. All right, so I have the limit as h goes to 0. It definitely looks like a definition of the derivative. Anytime that you see a limit as h goes to 0, and I don't even see the right-hand side, it's usually going to be a definition of the derivative. By the way, I should note that there are 3 definitions of the derivative. I'm showing you the most common one. There will be one on the pre-test, I think, where it's like, wait, I've never seen this before. It's a definition of the derivative because there's a limit as h goes to 0. All right, reading me off my steps. What am I doing? Help me. Let's go around the room. Let's start with Teflon, and we'll just go clockwise. Step 1, Teflon, go. All right, where is it? All right, so box that. Everything else, ignore. All right, Chris, what is our C? We'll write it down. read my note up here.
Leaving I to H.
What?
2.
2. There it is. Step 3, Fiona. Okay, so what am I doing for this function? There is a natural log of just x. Okay, and he basically did stuff for it first as well. So I'll say we now have the function. I can say down here, our function f of x is this natural log of x. All right, and Andrea, you're on step number 5. There it is. Yep. So I'll say f prime of x now, as Andrea said, that 1 over x. And now to Teflon, step number 6. Okay, so it's not f prime of x, it's f prime of 2, and that's equal to what? Yep. 1/2. And we box it. It's pretty crazy to think about that. We had all of this Chinese math, whatever you want to call it, all of these symbols, and this whole thing is 1/2. There it is. That's the end.